flip back on it. Then, so now when this is x squared, like the way we have written it there, it's going to be 4 equals to x squared plus 1, which you can take 1 the other side. We're going to be left with 4 minus 1 is 3 equals to x squared. We can apply the square root both side, square root both side. Then our x is going to be equals to square root of 3. So it means that our r equals to square root of 3. Then now, if I want to find cos of 30 degrees, this is degrees, remember, cos of 30 degrees is going to be adjacent over hypotenuse. So which means it's going to be square root of 3 over 2, and 30 degrees. We know that is opposite over hypotenuse, opposite over adjacent, which is 1 over square root of 3. So those are things that, this is a very special angle that you must always remember. So in this one here now, when we also have another one for 60, we have 3 of them, the special angles that you need to remember. The other one is when your angle is 60. When your angle is 60, when your angle is 60, if you say cos of 60 degrees, cos of 60 degrees, we know that is going to give you 1 over 2. And when it gives you 1 over 2, your cos of 60 is opposite, it's adjacent, which is going to be 1 over 2. So it also implies that the here is going to be square root of 3. So if you have to find sine 60, your sine 60 degrees equals to opposite, which is square root of 2, of 3 over 2, square root of 3 over 2. That's your cosine of 60. Square root of 3 over 2. And your tan of 60 equals to opposite over adjacent is square root of 3 over 1. Opposite over adjacent, which you can rewrite as a square root of 3. Then we also have another special angle. The other special angle we have a special angle of 45. The special angle of 45 degrees is when your 10, if you say 10, 45. So you must check that when it's 45, I start with 10. When it's 60, I start with cos 60. I know it's 1 over 2. When it's 30, I started with sine. I know sine 30 is 1 over 2. So 1045 is 1 over 1, which is 1. 1045 is 1. So when 1045 is 1, we know that is 1, which means here is going to be square root of 2. Then, if you want to find sine of 45 degrees, sine 45 is opposite over hypotenuse, which is going to be 1 over square root of 2. And cos 45 degrees also is opposite 1 over 2. 1 over square root of 2. So if you check something, you will find the relationship we have. If you check, since we have started here, you will notice that we have a relationship between those angles that we're writing. We found that sine of 30 degrees equals to cos 60 degrees, because all of them, they're equals to 1 over 2. And we have found also that sine of 45 degrees equals to sine cos of 45. So this is just something that you can take into account. Just like if you get us, you can just be knowing them so that like you can apply them maybe somewhere, somehow in any question that you might approach. So sine 45 degrees equals to cos 45 degrees, which is what 1 over square root of 2. Square root of 2. So now we're going to move to another level. Now we're going to move to another level. So the other level that we're going to move, we're going to talk about the reciprocal. Reciprocal. So when we talk about the reciprocal, what is reciprocal? Reciprocal in mathematics, I won't really give you the definition in terms of English, and I'm just going to tell you how you apply the reciprocal. But reciprocal is to make two things to be unit or to be together or to be equal, same. So now when we talk about the sine of theta, as I'm using theta today, sine of theta, the reciprocal of sine theta is 1 over sine of theta, and this 1 over sine of theta equals to cosec theta. I wish I can give somebody these brains. Equals to cosec theta. And cosec theta, sine theta is the reciprocal of cosec theta. And we also have cos theta. Cos of theta, the reciprocal of cos theta is the same as 1 over cos theta. And 1 over cos theta equals to sec theta. And tan theta equals to 1 over tan theta, which is equals to cot theta. So those are reciprocals of sine. So if you are working with cosec, you can change it to be 1 over sine if you are not able to work with cosec. If you are within sec, you can change it to 1 over cos theta. If you are working with cot, you can change it to 1 over tan theta. So now we have spoke about the reciprocal. So now we are going to go to the Cartesian, like we are going to draw a line like this x and y. Now we are moving to the identities, whereby we are going to work with angles. So we have something called cast. So normally when you see it in this graph, it's going to start with C in this one. Here AC cast. Here is going to be S and T. So this cast, when you read it, this means cos, this means all, this means sine, this means tan. So it means that this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. So now, in the first quadrant, it means all are positive. It means all are positive. When we say all are positive, sine, cos, and sine, cos, and tan, they are all positive. But in the second quadrant, only sine is positive. And in the third quadrant, only tan is positive. And in the fourth quadrant, only cos is positive. So from going to the first quadrant, here is like going to 0 to 90. So here we work with things like 90 minus of theta. And here, after, if we say plus, we go, if we say 90 degrees plus theta, this is the second quadrant. And if we can say 180 degrees minus theta is still in the second quadrant. But the moment when we say 180 degrees plus theta is in the third quadrant. And if we can say 270 degrees minus theta is in the third quadrant, and 270 degrees plus theta is in the third quadrant, fourth quadrant, and 360 degrees minus theta is also in the what? In the third quadrant, which is going to tell us that if we say 360 degrees plus theta is in the what? In the first quadrant. So knowing everything that I've just written there on top now, we can work any angle. So if you are given, let's say, sine of 90 degrees minus theta, this and 90 degrees minus theta, we know that it's going to be positive, but it's just that when we work with say 90 degrees minus theta or cos 90 degrees minus theta, the only when it's 90, they are very special. They change to, this one changes to sine. And the other one, this when it's sine, it changes to cos, and when it's cos, it changes to sine. So we are going to prove that. So before we even take it further with what we are doing, I'm going to give you another identities that I'm going to work with you. We have an identity, the identity that I'm going to give it to you now. It say if you have a sine of A plus B, sine A plus B, sine of A plus B is the same as sine. It's also there in your memo, not in your memo, I mean in your formula sheet in grade 12. Have you seen it? Sine A plus B is the same as sine of A dot cos of B plus cos of A sine B. And if you have sine of A again minus B, this is the same as sine A cos B minus cos A sine B. And if you have cos of A plus B, this is the same as cos A cos B minus, when it's plus, when it's cos, yeah, when it's plus, your sign here, it changes to negative. It's gonna minus sine A sine B. So if you have cos of A minus B, this is the same as cos A cos B plus, because it's negative, it becomes plus here, plus sine A sine B. Yes. So we have these identities. So the other identity that you must also know is that if you have sine 2A is the same as 2 sine of A cos of A. And if you have cos 2B, 2A is the same as cos squared A minus sine squared B, sine squared A, sorry, not B, sine squared A. So these identities, but these two identities, they are coming from those identities that we just put there. We're still gonna prove them. So now I just wanted you to take into account these identities that I just gave it to you. Now, so that when I use them to show you what is sine 90, So if I have sine of 90 degrees minus theta, I can write it as equals to sine 90 degrees dot sine of theta minus cos, not sine theta, I made a mistake. You must correct me if I'm making mistakes. It's supposed to sine 90 cos theta, cos of theta minus cos 90 degrees sine theta. So sine 90, if you use your calculator, you might find that sine 90 equals to 1. So now normally there is no need for us to use a calculator. What we can also do, we can draw a graph of sine 90 of sine theta. When we draw a graph of sine theta, going to be this way and this way. So we know that it's going to start at 90, 180 degrees, 270, and 360 degrees. 90, 180, 270, and 360 degrees. So here is going to be 1 and 1, negative 1. So now sine 90, we know that sine 0 is going to be 0. So sine 90, the sine graph, it goes this way. You see how it's moving. This is a graph of sine 90. Sine theta, not sine 90. You will see that when sine is 90, your graph sine 90 is 1. So here, which means here is going to have 1 cos of theta. And for cos theta, cos when is 0, it is 1. Eh? So cos theta graph, it goes this way. It will touch at 90, touches 270 like that. It will go to touch at 90. Touch at 90. Go to 270 and that. So this one here is sine theta, and this one is cos of theta. So you will see that when cos is 90, cos 90 is what? Is 0. Then it's going to be minus 0 dot sine of theta. So when you check it, the final answer is going to be equals to what? Cos of theta. So I just prove it to you using the identities that we just did, the special identities. So now you know that your sine of 90 degrees minus theta equals to what? Equals to cos of theta. We prove that. So many learners, they make mistake of this one. They think I sine 90. When you say 90, it's going to be sine because of it's going to be a positive sign. So, but in these two, they are not. So even if you are saying cos, if we have to find cos 90 degrees minus theta, it's not the same as you're going to get sine cos. So we can also prove it. What is cos 90 minus theta? It's going to be cos.
Sorry.
Hello?
I don't understand the graph.
Okay, let me go back to the graphs. The graph of sine, you see the way I've drawn them here.
Yes.
This graph here, this one is for sine. The first one here, the one which start at 0, is for sine. So what happened when we plot the graph? If you say sine 0 in your calculator, you're going to find that is 0. You put a dot here. If you go, then when you draw your graphs first, you're going to draw as 0, 90. The interval is going to be 0, 90, 180, 270, 360, the way I've done in the X side. Then here we wrote, if you see, I wrote 1 because I know that is going to, they play between 1 and -1. So if you use your calculator now, check your calculator. When you draw it, you're going to start by sine 0. If you say sine 0, you're going to get 0. You put a dot. Ne? Then you go to 90. If you say sine 90, using your calculator, it's going to be 1. On the 1, then you put a dot. Then if you say sine 180, it's going to give you 0. You put a dot. If you say sine 270, you're going to give you -1. You put a dot. Then when you say sine 360, it's going to give you 0. You put a dot. Ne? Then you join those dots this
Okay,
way.
now I
Now you
understand.
understand, ne? So it's just that the moment when you start to know them, you won't have a problem. So it works with the cos. For the cos 1, if you say cos 0, cos 0 is going to give you 1. Even if you use your calculator now. Are you having your calculator with you?
It's,
Press
yeah,
cos 0. Press cos 0.
it's giving me 1.
1. When it gives you 1, you put a dot, ne? Here on 1. You go to cos 90, it's going to give you 0. You put a dot. You go to cos 180, it's going to give you -1. You put a dot. You go to cos 270, it's going to give you 0. You put a dot. You go to cos 360, it's going to give you 1. You put a dot. Then you join those dotties, drawing a line like this, following those dotties. Then it's going to give you graph like this. Then you do the same in the negative side. This is negative, negative, negative. You're going to see that when you join those dotties, it's going to give you this graph, of course. So do you understand how you draw it now?
Yes, I do.
Hello?
I understand now.
Okay. So that's how we work with those graphs. We're still going to do this graph also. So now, when we use this one here, cos of 90 degrees minus theta, is going to say cos 90. We are following that formula. You remember the formula? It says cos 90, and then it's going to say cos theta. Because it's plus, if it's cos, we minus, if it's cos, we say plus. Then it's going to say sine 90 degrees sine theta. So you can even use a calculator. What is cos 90? Cos 90 is 0 dot cos theta. And what is plus? What is sine 90? Sine 90, if you use a calculator, you're going to find that is 1 sine theta. The sine theta is this one. Then this identity is you're going to see that is sine of theta. So now you can see that, okay, when you say cos 90 minus theta equals to what? Equals to sine of theta. So now, because I have shown you, you don't have to write this. You must always remember when you are studying, remember that cosine of 90 degrees minus theta equals to cos 90, and the cos 90 minus theta equals to sine theta. Sine theta. Yes, you must remember these two identities. So now we're also gonna go to check what if you have cos of 90 degrees plus theta. We were working with the minus. Cos 90 degrees plus theta, we use the same identities that I gave it to you. You're gonna say it's cos of 90 degrees dot cos theta. Because it's plus, it's gonna be minus sine of 90 degrees sine of theta. So this is going to be equals to, cos 90, we know that is going to be 0. It's going to be 0 sine of theta minus sine 90, we know that is going to be 1 sine, no, not sine theta. Here is cos, ne? Cos of theta, this one, sine theta. So, but the final answer we're going to have minus sine of theta. So do you see that when you have cos 90 plus, your answer is minus. So what about if you have sine of 90 degrees plus theta? Cos 90 degrees plus theta, is going to be cos of 90 degrees. Sorry.
Sine.
Yeah, it's sine. Yeah, right. I made a mistake. So it's going to be sine 90 degrees cos of theta. Because it's plus, it's still going to be plus, and we're going to have cos 90 degrees sine of theta. So when we answer this one, this is going to be sine 90, we know it's going to be 1 cos of theta plus cos 90 is 0 sine of theta. Then the answer is equals to cos of theta. So now cos of theta. So now you know that cos of 90 degrees plus theta equals to negative sine theta, and sine plus theta, sine of 90 plus theta equals to cos, is positive cos theta. So now you have these 4 identities. 1, you can memorize them. 2, and the others 3 and 4. When is 90? Those are the special ones that those are just a special one that you can use, you can remember. So do you want to drink some water? I can give you 2 minutes because we're still going to have a long class.
No, fine.
Yeah, fine. All right. So now at least you can see what's going on. So we're going to move to when is 180. 180 and going forward is simple. There are no So let's go when sine. When you have this one, you only remember the graph. Ne? You only remember the graph. Let me draw the graph. Is cast. Now you know what is cast already shown. So if we say we want to find sine of 180 degrees minus theta. So what sine 180 degrees minus theta, it fall under this second quadrant. This is the first quadrant. This is a second quadrant. This is a third quadrant. And this is a fourth quadrant. Sine 90 degrees minus theta is equals to sine of theta. But if we can say sine of 180 degrees plus theta, sine 180 plus theta is no longer in the second quadrant. Is in the third quadrant. And the third quadrant, sine is negative there. So the answer becomes negative sine of theta. And if we can say sine 270 degrees minus theta. Sine 270 degrees minus theta is in the third quadrant. And in third quadrant, this sine here is what? It's negative. So which means the answer becomes negative sine what? Sine theta. You see, it's very simple. So let's go when, if we want to, I want to write all of them from first, second until the fourth. If I can say sine 270 degrees plus theta, 270 degrees plus theta is in the fourth quadrant. Then we know that our sign here is negative. Want to be negative sine of theta. And if we can say sine 360 degrees minus theta is still in the fourth quadrant, which means in the fourth quadrant, sine is what? Is negative. It's going to be negative sine what? Sine theta. You write this every time when you see all these identities that I just wrote down, you write exactly what I have just wrote now. So now let's go to cos. If we say cos of 180 degrees minus theta, cos 180 minus theta is in the second quadrant where cos is negative. Né? So normally when you are writing your exam, just draw on top of, when you start doing, let's say for trig, just draw this graph and say cast so that you can remember. Maybe you can even write 180 minus what was, so that you can remember. So cos 180 minus theta is in the second quadrant. And in second quadrant, cos is negative, which means it's going to be negative cos theta. And cos 180 degrees plus theta is in the third quadrant. Third quadrant is 10. Cos is negative. You see, the result becomes negative cos of theta. And cos of 270 degrees minus theta. 270 minus theta is in the third quadrant. Still third quadrant, cos is negative. The result is cos theta. And cos 270 degrees plus theta is in the third quadrant, fourth quadrant. Fourth quadrant, that's when cos is positive. Then which means we're going to have a positive cos theta. You see? And also, if I say cos of 360 degrees minus theta, this is in the fourth quadrant. And in the fourth quadrant, cos is positive. It's going to be cos of theta. And we also have another one which I didn't mention. Here I'm going to add, if we have sine of 360 degrees plus theta. Sine 360 degrees plus theta is in the first quadrant. I have shown you that before. So when it's in the first quadrant, everything in first quadrant is positive. Then, which means here the answer is sine theta. And here for cos, if we say cos of 360 degrees plus theta, 360 degrees plus theta is in the first quadrant. The first quadrant, everything is what is positive. Then the answer is going to be cos of theta. So we can also do the same as in 10. So now I'm going to do something. You are using your tablet, right? So I'm going to make you also a host. Make you a presenter. I want to, is it you, did you download the one for writing? You can use your hand to write. Did you download it? Yes. So now I'm going to want you to write for me for cos for 10, exactly the same way I was doing. So are you ready?
How do I do it?
Hello?
How do I write?
Okay. The first thing you have to present, you have to, let me stop sharing. Go to share and you share your screen.
Where is share?
Yeah, you go share. Do you see a place to return share?
I'm looking for the share screen. Yeah, it's here.
Yes, and you must share your entire screen so that I can see what you are doing.
And then
I can see. Then now go to that app for writing, the one I said you must download. Yes, whiteboard, I can see it. Then you can start writing. Just say agree with their policies. Yes, there is a pen there, you can write. If you start writing, it's gonna write. So I want you to start writing for 10, the way I was doing.
yeah. 1 3 minus theta
Yes.
minus 10.
You must put also the brackets after theta. You are doing it well. It's very nice. I'm loving that. Yes, you can continue. You're right. Everything.
Minus plus cos 180 plus
Mhm. Great, great, great. Don't forget brackets. It's very important. I'm not gonna say it again, as you already forgot in the middle one.
Which one?
Or 10, 180 plus. You didn't write the brackets at the end. You can, okay, it's fine, but you can continue.
Done.
Okay, let me check. Tan 360, 170. You did it. You did that one, 270, 360. 270, what happened? Plus, okay, it's fine. 180, yes. Correct, that's nice. So now, which means I understand that you understand this. So now, I'm going to share, you can, okay, let me share my screen. Can you see my screen now?
Yes, I can.
Okay, now when you understand this, so now you already able to do much of the three questions. So now we are going to tackle one question together. So you will gonna start enjoying it. You're gonna see that this is very nice. You are in grade 12, right? I will even send you this past paper. Grade 12 past paper, let's get for 2022. Yes, 2022 is gonna be better. So this is the government website. You can also use it to download question papers and you treat them. Some of the question papers, they have memos.
Is it the 2022?
We are going to maths, ne?
Yeah, is it 2022?
Hello?
Is it 2022?
Yes, we are going to, for 2022, it's 2022. So here we are going to paper 2 for English.
No.
The first one I'm gonna download. So for me, I don't need a memo. I'm a memo by myself. So now we have the first questions, ne? It's a given that square root of 13 sine x plus 3 equals to 0, where x element, this is x element 90 degrees and 270. Without a use of calculator, determine the value of. So now let me just download this paper quickly. I'm gonna be writing on top of it. So now when you check here, you will see that in that questions, it's question number first one, yes. So now when you work, you know now what is sine 360 plus x?
360 plus x.
According to what we did, what do you know about sine 3x plus x?
It's equal to sine x.
Thank you. That's the best. That's when we are talking now. This is equals to sine x. You write it as equals to sine x. But here you are given that this identity. Ne? The first thing that we're going to do, you will take out these three, the other side. Ne? You're going to be left. You don't even hurry in mathematics. You're going to be left with sine x equals to what? Minus 3. Ne? You divide by square root of 3. Then your sine x equals to what? Minus 3 over square root of 13. You see that? So now they said this is sine x. Ne? Sine 360 plus is sine x. What is sine x? What is sine x? Sine x equals to negative what? 3 over square root of 13. You write it. You are done. What is 10x? 10x. Now when you have this, you have this one. Ne? Negative 3 over square root of 13. You draw a triangle in order for you to, you know that sine x is opposite. Opposite is going to be minus 3 over our hypotenuse, which is square root of 13. You see that what I'm doing?
Yes, I see.
Then you use a Pythagoras. When you use Pythagoras, Pythagoras says x squared r squared equals to x squared plus y squared. Then this one is going to be x, this r squared is going to be 13 equals to x squared plus what? Negative 3 squared, which is going to be 9, ne? Positive 9. When we take this one the other side, it's going to say 13 minus 9 is going to be 4, ne? 4 equals to x squared. So if you put the square root both side, you will see that your x equals to what? Equals to 2. Then which means x side is 2. So what is 10x? 10x, you use this graph. Here you put your theta. 10x or your x, let's use x. 10x is opposite over adjacent, which means it's negative 3 over what? Over 2. What is cos 180 plus? Now you know what is cos 180. Cos 180, when it's plus, is in the second what? In the third quadrant. And cos in the third quadrant is what? Is negative. Eh? Is negative cos of x. You see that what we're doing is very important. Then when it's negative cos x, then this is the same as negative. What is cos x in this graph that we just drew now? It's going to be adjacent 2 over square root of 13. You are done. You see, it's very simple to answer them when you understand the rules.
Yes.
We just, now, according to the things, to the lesson that we did, you just scored now. You already know now that in trigonometry, you already have what? You already have 7 marks. Now we go to this one. When you answer, determine the value of the following expression without a use of calculator. Here we don't need a calculator. We are just doing it. We are just doing what we know. So what is cos 90 plus theta? I already showed you already. If you can memorize them, oh, you remember cos 90 plus theta, it changes to what? To sine, right? But when it's positive here, does it becomes cos 90, it becomes negative sine theta. Né? If you can't, you can even prove it in the paper. It was it sine theta that time when we did it. Cos, okay. Yes, it's negative sine theta. Né? You must watch back. I'm going to send you this video. You must watch it so that you remember. But we are applying those rules that we did. If you cannot remember sine A plus B, you can use it as sine 90 cos theta minus sine 90 sine theta. Then you work it out. You use your calculator. What is 990? Then you're going to see that your answer is going to end up at negative sine theta. Then minus. So now here they are trying to fool you here. They want to see if you are smart, if you can qualify to go to university, if you can think. They write theta minus sine 180. Okay, you can say now we never done something like theta minus 180. So what you do, okay, you can say, okay, what can I do with theta minus 180? 180 degrees. You can write it as, okay, this is the same as I can write it as theta minus 180 degrees. You see that plus theta.
Mm,
You see
yeah.
that. Then now you can take out the negative sign. You don't, in mathematics, we don't rush. The moment when you start rushing in maths, you already fail maths. When you rush, people run fast in mathematics. They don't make it. Then you say brackets. You put another brackets properly. Say, okay, I'm going to take out the negative. Then you're going to have negative 180 degrees minus theta. You see that? Another brackets like that. We took out the negative. Now, you can, this, because this negative, it can be outside of here. You can write this as negative sign 180 degrees minus theta. Then you know what is negative. You know that if here sine of 180 minus theta, you know that is positive. It's going to be sine theta, but it's going to be affected by this negative. Then which means your answer is going to be negative sine of theta. You see that how we work it out properly with just simple mathematics. This one plus here, this negative theta here, negative, it can go out. We can say minus 3 sine what? Sine of theta. So now we know, you know about the like terms. When we talk about like terms, if things are the like in the if things are the same, we can add them and we can subtract them. So you will see that here you have minus sine theta minus 3 sine theta. Minus sine theta minus 3 sine theta. It can be minus what? Minus 4. It's like minus 1 minus 3 minus 4 sine theta. So we can write this identity as negative sine of theta over negative 4 sine what? Sine theta. So this one here, this will cancel with this. Then you are going to be left with negative 1 over negative 4, which you can write it as 1 over 4. So the answer for this is what? Is 1 over 4. We just work it out properly. So you can work it out step by step by step.
What happened to the negatives?
Negative divided by negative equals to positive. I think I
Okay.
already told you in the previous lessons. So we're gonna stop. This one says determine the general solution of the following equation. We haven't touched a general solution now. We want to do it now. We're gonna go back. We're gonna leave it. We are only doing questions that we already covered today. So it says given the identity cos x plus y dot cos negative minus y equals to that. They say prove the identity. When you prove this identity, you have the other side is, we call it left hand side. The other side is right hand side. Left hand side, we can just say left hand side, we can write it as this way. And right hand side, we can write it as this way. So is either you can take the left hand side or you can take the right hand side. Then when you prove, it must give you the right hand side. So normally when you have this kind of questions, you must take the one that you can see that if I prove, it will take me quickly to the other one. So we can see that the left hand side, if we use it, it's going to give us this one quickly, because this one, if we try to use it, it might be hard for you to get this kind of equation. So in order for me to prove this, I can say, okay, my left hand side equals to, I can rewrite it first so that I don't make mistakes. Cos of x plus y, cos of x minus y. So now this is going to be equals to, we know what is cos x plus y. What is cos x plus y is going to be cos x. I already shown you that, cos x, cos what? Cos y, minus, because it's plus here, it's going to say minus sine x sine y. Then what is cos x minus y is going to be cos, you can put brackets, it's going to be cos x sine y minus cos x sine y. Sorry, not cos x sine y, it's cos x cos y, ne? It's cos. And then sine minus, here if it's plus, it's minus. If it's minus, it's plus. Plus sine what? Sine x sine y. So just because something, it looks very long, it does not mean that you must not do it. It can be long, but you can work it out. So now when we have this, what can we do? We can multiply back. Here it's like factorizing. Cos x cos y multiply by cos x cos y. Cos x cos y multiply by cos x cos y. You can see that this is cos x cos y. You can write it as cos. We're going to have a cos squared x cos squared y. Ne? Then you multiply cos x cos y multiply by sine x and y. You will have to, we're gonna have plus cos x cos y sine x sine y. Then you come to this one, negative sine x sine y is going to be minus. You write minus sine x sine y, and then cos x, this one times this one times this one, cos x cos y. Then this one times this one is going to be negative. Sine x and x is going to give us sine squared x cosine squared y. Okay? So you will see that these identities, they are the same, is plus. They are exactly the same. Is cos x cos y. We have cos x cos y, sine x and y, sine x cos y. This is going to cancel with each other. We are going to have 0. Then we're going to be left only with cos squared x cos squared y minus sine squared x cos, sorry, not cos, is sine squared again, sine squared y sine squared y. So, but we also have to check which answer did this. Here we have that this identity is equals to 1 minus sine squared x minus sine squared y. All right. So now you can see, but this answer is not closer to what we have just did then. What can we do? You think about everything that you know. We know that, okay, our answer is in the form of sine. What can we do? We know the identities that says, which I've already given it to you, that cos squared x equals to 1 minus sine squared x, which means we can change these two identities to be in the form of 1 minus sine squared x. Then when we change them, our cos squared x is going to be 1 minus sine squared x. You put brackets, cos squared y is going to be 1 minus sine squared y. Ne? Then minus sine squared x cos squared y. Then now we can multiply back this one. 1 times 1 is going to give you 1. 1 times minus sine y squared is going to be minus sine squared y. And then you come to this one, minus sine squared x times 1 is going to be minus sine squared x. Minus times this one is going to be plus sine squared x sine. There is x and y, sine squared y. They are x and y, they are not the same. Then let me delete this here so that I can write properly. Then we also have minus sine squared x cos. Is it cos? No, it can't be cos. It's sine squared x sine. Yeah, I just made a mistake here. It's sine squared y, ne? Sine squared y. Now we can check. Now we are greater. If we go closer to check again, now it's like we are getting there. We have 1 minus sine squared x minus cos squared y. So now we can check. What can we do here? We have 1 minus sine squared x minus sine squared y. But we also have sine squared x, sine squared y minus these two. You can see they will cancel now. Do you see that? Then we're going to be left with 1 minus sine squared y minus sine squared x, which is exactly equals to what? The right hand side. You can check it. Is exactly equals to what? Our right hand side. You see that is exactly the same. But we solve it very well without doing what? Without having to take a shortcut. So it means what you must learn is that we don't have a shortcut. We don't do what shortcut. The moment when you start shortcut in mathematics, you are going to get it wrong. So now what I'm going to do, I'm going to get another question paper. We are still in class. I'm going to let you do questions that